So this is the second session on the topic signals and systems, and we are going to study how to write a MATLAB program to generate a signal. And specifically in this session, we are going to study how to generate an analog sine wave or a continuous time sine wave through a MATLAB program. That is what we are going to study. So let us start. So this is what we want to do, generate an analog signal through a computer program. But before we look at the program, we would like to study the techniques first. So let us look at them. Note that for any signal, the general equation is x is equal to function of t. In our case, in this session, this function is going to be a sine wave. However, these remarks are quite general for any analog signal. Now in this, both x and t are continuous variables. So the question is now, how do you declare these variables in your MATLAB program? And the answer to that is that we designate both x and t as floating point variables. Now note that using them as floating point variables does not mean that you get perfectly continuous variables. So strictly speaking, these variables are not continuous because computer word cannot use infinite bits. Remember, if you have got large number of bits, then only the quantization error is small and the signal tends to be continuous. So ideally you will require infinite bits, which is impossible. So strictly speaking, the simulation that we do will not be absolutely perfect. There will be some error. However, the error is small because generally the number of bits in the modern computers is quite large. And in order to give you an example of this, if you consider a 64-bit machine, then if you consider the smallest possible positive increment from 0, then that is as small as 4.95 into 10 raised to minus 324. So you can imagine this is an extremely small increment, and because of this, for all practical purposes, we can approximate these variables as continuous variables. But important point to note is that whenever you want any variable to be simulated as a continuous variable, you declare it as a floating point variable and you get approximately continuous variable. All right, what else? So again, we continue our study of technique for generating a sine wave. What are the various statements in the algorithm? So suppose we want to generate x equal to a sine 2 pi ft. So what will be the inputs to the program? Amplitude, that is a fixed quantity. So this can be put in a statement or maybe user can input it, depends on how you write the program. So a is the amplitude. This is one of the inputs. F is the frequency of the sine wave. Again, it can be put in a statement. This is another constant. Then small t is an array. So that at t equal to 0, you will get some value of x, which in this case is going to be 0. Then you will increment t to some value, say t1, calculate x1. Then increment it further to a new value t2, calculate x2, and so on. And finally plot x as a function of t. That is what you do. All right. So let us now, before proceeding further, note that f is the frequency of the sine wave. And we can calculate the time period of the sine wave, as all of us know, by taking the reciprocal of the frequency. Later on, we'll see what is the use for doing this particular calculation. But we do this calculation. Now, to plot x as a function of time, we need to vary t. So, say t1, t2, t3, etc. and calculate x1 and x2, etc. and plot x as a function of time. This is something I have already said. It's repeated here for convenience. Then the plot command in MATLAB, what it does is it joins the consecutive points through straight lines. That is what it does. So even if it's a curve, if you look at the nature of the graph between two consecutive points, it's a straight line. So clearly, if you want your curve to look smooth, larger the number of points you have, better it is going to be. Okay. So now we again look at the sampling frequency, something we have explained before, but in relation to MATLAB program, where it comes in, that is what we want to study. So the variable t is an array such that t1 is equal to 0. You start from t equal to 0. You could start from some negative times also, which we shall later on show in the later programs. But let's say we start with 0. So t1 is 0. Then t2 is how much? So t2 is away from t1 by a time which we call as a sampling time, which is ts. Then T3 is again away from the second sample by Ts. So T2 will be Ts, T3 will be 2Ts, and so on. So this is the sampling time. We have already studied in the previous session how this sampling time is selected, but we'll again look at the details here also. So Ts is called the sampling time and should be such that Ts is much smaller than capital T, where capital T is the time period of the sine wave. So Ts should be much smaller than T. So this will give large number of points for a smooth curve. So the question is how small Ts should be. So what we'll do is we'll take a couple of examples. One in which we'll say Ts is say T by 10, and we'll be able to see that we do not get a very good sine wave. So we can reduce Ts further and so on. Notice that when Ts is much smaller than T, and since T is a reciprocal of the frequency f, this condition equivalently can also be written as Fs is much greater than f, where Fs is the sampling frequency which is reciprocal of Ts. Alright. Now another aspect before looking at the program is how many cycles we want to plot. So we may want to plot only say 1 cycle, 2 cycle, 3 cycles and so on. Of course the space on your screen is limited. So if you draw a very large number of cycles, you may not be able to see the sine wave at all. It will look all solid curve. So you decide how many cycles you want to plot. So suppose n is the number of cycles we want to plot. So we generate our time array in this fashion: t equal to 0 colon ts colon nt. This is one of the statements that you can write in the MATLAB program, and this automatically generates an array for t. So when this statement is executed, what the program will do is it will force t1 to be equal to 0, t2 to be equal to ts, t3 equal to 2ts and so on, and the final value will be n into t. Note that if n is equal to 1, then the final value is the time period of the sine wave itself. This is the time period of one cycle. So if n is equal to 1, then what you will see is one cycle of the sine wave. If n is equal to 2, what you will see will be 2 cycles of the sine wave and so on. Okay, so now we are ready to look at the program. So the first line is, as usual, clear console, clear variables, clear figure, because we are going to plot a figure. So whatever previous figures were there in the memory, we would like to delete them. Then A is equal to 1. This could be something else. This is the amplitude of the sine wave. So it may be 1, 0.5, 2, 3, whatever you want. So in this example, I am assuming that we want to generate a sine wave with an amplitude 1. And let's say we want to generate a sine wave with a frequency of 100 cycles per second or 100 hertz. Again, this could be something else. Alright. Then what you do is you calculate t first. Remember, we require this because we want to plot certain number of cycles, and that can be easily plotted by defining the last value of time appropriately in terms of t. That is why we calculate t. So t is 1 by f. Alright. Then you decide the sampling time. So it should be small compared with t. In this case, we are saying it is 1/10 of t. And we will see that in fact, this sampling time is not small enough to give us a good curve. So later on, we'll modify this. But just now, we just want to demonstrate this. All right. Incidentally, note that Ts equal to t by 10 also means that the sampling frequency is 10 times the frequency of the sine wave. Because remember, sampling frequency is reciprocal of the sampling time period, and the frequency of the sine wave itself is reciprocal of its own frequency. Okay. Now let's say n equal to 5. So in this case, I am assuming that we want to see 5 cycles of the sine wave. And this is not something which is cast in stone. This depends on what you want to see. If you want to see only one cycle in more detail, you can plot we can choose n equal to 1 only. If you want to switch 10 cycles, you can choose n equal to 10 and so on. So later on, when you enter this program and run it, you can change some of the constants here and see the effect. All right. So as we have already explained, you now generate the vector t which starts from 0 and ends at nt because we want to plot n cycles. All right. Now x equal to a sine 2 pi ft. So what this statement does, it will actually generate an array for x, and the number of samples in x will be equal to the number of samples in t, because after all others are constant. T is the only array. So what this statement will do is it will take first value of t, say t1, generate x1, then it will take t2, generate x2 and so on. So you don't have to do this separately in MATLAB. A single statement is capable of generating an array for x given the array for t, which is already generated here. All right. So now you want to plot this. So you say plot t comma x. So t will come on the x-axis and x will come on the y-axis. Okay. And the line width, you select line width. So typical value may be 2. If you want line width to be, if you want a thicker line, this can be 3. If you want a thinner line, this can be 1 and so on. So you can play with this. Grid on. So you can also see the graphical grid in the graph by using this statement. Then x label. So what is the label for the x-axis? So that is, you write time t. Again, this is under your control. You could have written just t only. In this case, I have written time t. Then y label, amplitude x, title, sine wave. So once you enter this program and execute it, you will get this graph. So you can see the grid lines are there, although they are somewhat faint. And you can see that since n is equal to 5, you got 5 cycles. So this is 1, 2, 3, 4 and 5 cycles. And notice that since f is equal to 100, your time period is 0.01. So since you are plotting 5 cycles of this, the highest value of the time is equal to 0.05, 0.01 multiplied by 5. So this is what, and it starts from 0. Amplitude, we have selected a equal to 1, so this reaches maximum value of 1. Okay, but in this case it's not able to reach, and that is because our sampling time is not small enough. In fact, if you look at this sine wave, the quality is not too good. These are all piecewise linear functions. So this is linear, this is linear, again this is linear and so on. So this doesn't look like a good sine wave. So if you want to plot a good analog signal, 3 things you must note. One is you must use you must use floating point variables that will simulate the continuous variable. So you use floating point for t and you also use floating point for the amplitude. These 2 things are a must. But the third important thing is that the sampling time that you select should be quite small compared with the time period of this sine wave. So t by 10 is not small enough. So what we are going to do is increase this to, say, this constant to 100 and see what happens. That will mean that your sampling frequency is 100 times the frequency of the sine wave. So now I'll show you the complete program again, but with whatever modification we are doing, that will be highlighted. So rest of the program is same, but what we have done is Ts is t by 100, which means the sampling frequency is now 100 times f. That is what it means. And now if you plot the sine wave, when you execute this program, this is what you get. You can see it's now able to reach the amplitude 1. You get a much smoother curve. The rest of the things are same, is from 0 to 0.05. The amplitude is 1 and you get a much smoother sine wave. Okay. Next, suppose, see, we plotted that sine wave from t equal to 0 to t equal to 5 times t. That's what we did. But suppose you want to plot it from negative values of time. Then you need to change the statements a little. So again, the whole program is same, except where there is a change in the program, I have highlighted by using the red color. So n equal to 3. So what we are doing actually is changing the number of cycles. But now t starts from a negative value. So your t1 will be minus nt. So minus 3t. So t itself is 0.01. So it will start from minus 0.03 and will go up to plus 0.03. And since you're starting from negative, although n is equal to 3, you will now see 6 cycles. So let us see this. So you can see 1, 2, 3, 4, 5, 6 cycles you see. It starts from minus 0.03 because you have written minus nt, goes up to plus nt 0.03. So the rest of the things are similar. Okay, so that is how you plot the sine wave. Let us modify this further a little bit. Suppose we want to generate a cosine wave also and plot both sine and cosine waves. Then what do we do? So we say a equal to 1. Again, whatever is repeated is in black and whatever extra is there, whatever is changed is in red. So we are now defining a phase angle that is equal to pi by 2. Remember, if you want to generate a cosine wave, one way of doing it would be to simply add the phase angle of 90 degrees in the angle parameter. That is the way. Now in this particular program, we want to plot sine as well as cosine. So we'll generate both of them and plot both of them on the same graph. That is what we are going to do. So n is equal to 1. So in this case, we are going to plot 2 cycles because it's starting from minus nt to plus nt. So although n is equal to 1, since we start from negative, we'll see 2 cycles. Then our x is the sine wave which we had plotted earlier. Now y is the cosine wave, but how that is obtained? By adding this angle which is pi by 2 to the sine wave. So y essentially becomes the cosine wave. The rest of the things are similar, but now what you have to do, once you have plotted the sine wave, you need to plot the cosine wave also on the same graph. So in order to be able to do that, you use a statement called hold on. So hold on, what it will do, it will generate the next graph and put it in the same screen, the same graph screen there. So let us see the result. You can see here, the blue line is here representing a sine wave. It starts from 0 and there are 2 cycles of this, whereas the cosine wave starts from 1 because it is leading the sine wave by 90 degrees, and the rest of the things are similar. This also has 2 cycles. As you can see, starts from positive. So in this particular session, we have done some general discussion on how to plot analog signals in general, and then we have illustrated it with a specific example of how to plot sine wave, cosine wave, and so on. In some subsequent sessions, we'll see some other signals also, and we'll also see how to plot the digital signals using a MATLAB program. But for now, we end here.